Hello my dear students, welcome back to Easy Notes. Today we'll be continuing the chapter Refraction Through Lens, in which we'll be studying about part C, that is sign conventions. How to assign the signs for what? Three things: object distance, image distance and focal length. These three things we'll be studying. So firstly, sign convention. The object placed, let us study here. Let us consider this is a lens. Which is this lens? Convex lens. Okay. Object is always placed to the left of the lens. Here this is object, okay, and this is our optic center. Okay, so if the object is placed here, where will be the image formed? Somewhere here, right? Somewhere here somewhere here it's forming, right? It's forming somewhere here. There is an image formed. So this is nothing but our image. Okay, so from here to here, from this point to this point will be object distance u, and from here till here it will be v, image distance v. And if here is the focal length f, this will be small f, right? We know that about focal length. We know the distance from focus to optic center is called focal length. We just need to know object distance and image distance. Okay, so every time object is placed left to the where? Lens. Now if now the rays will come in this way, right? If we measure anything in the direction of incident ray, it will be positive. See, always we have to measure it from optical center. Always we need to measure any distance from optic center. From here we will be measuring. Okay, now if we measure from here to here, that is nothing but v. We are measuring from here to here, it will be positive if we go like this. But if we measure like this u, that is nothing but it will be negative. Okay, in the direction of ray, in the direction of incident ray it will be positive. Opposite to the direction of incident ray will be negative. This is principal axis, right? Above principal axis will be positive, below principal axis will be negative. Only this much you need to remember. See here, the object is placed on the principal axis to the left of the lens. That one thing. All distances are measured from the optical center along the principal axis. Second thing, distances measured in the direction of incident ray are positive, and those opposite to the direction of incident light are negative. We know that. Next, heights measured above principal axis are positive, heights measured below principal axis are negative. So according to sign convention, these are the only rules. Okay, only 4 rules. According to sign conventions, what happens? Focal length of convex lens is positive. Always remember, focal length of convex lens is always positive, because in convex lens we measure, this is f1, right? F1 or f2? This is f2. This is what? F2. Here it is f1. So if they say focal length, that is nothing but they are talking about principal focus, that is f2. So this will always be positive. This will be positive for convex lens. Focal length of concave lens will be negative, because we will be measuring f1 there, right? Opposite to the direction of incident ray. Object distance is always negative. Remember, object distance is always negative. Focal length you need to remember, for convex positive, for concave negative. Object distance always negative. For any lens it will be negative. Image distance is positive for real images and negative for virtual images. Positive for real, negative for virtual. Positive for real, negative for virtual. Simple. Focal length is positive for convex lens, focal length is negative for concave lens. Object distance is always negative, but image distance is positive for real images, negative for virtual images. Okay, okay. Next thing, lens formula, by which we can find the any of these things. They'll give 2 things, either object and image distance. They'll ask us to find focal length. There is a relation between these 3 things. The relation between object distance, image distance and focal length of a lens is given by lens formula. That is nothing but 1 by f is equal to 1 by v minus 1 by u. This is the lens formula, where f is focal length, v is image distance and u is object distance. Next, magnification. What do you mean by magnification? Magnification means, compared to object, how about image? Is the image bigger or smaller? That is nothing but magnification. The ratio of length of image perpendicular to the principal axis to the length of object is called linear magnification. That is nothing but height of image with respect to height of object is called magnification, or we can say it as V by U. After solving, we'll get V by U, where V is image distance and U is object distance. And magnification does not depend on focal length. Magnification, remember, magnification does not depend on focal length. Okay, so what is magnification? Magnification is the ratio of image height with respect to object height. It's nothing but the size of image with respect to size of object is called magnification. Next, note point we need to remember. For real and inverted images, magnification is negative. Remember, for real and inverted, magnification is negative. For virtual and erect, magnification is positive. Erect means positive, inverted means negative. Simple. Remember like that. Inverted means downward, right? Negative. Erect means upward, positive. Okay. A convex lens can have positive or negative magnification, but a concave lens has always a positive magnification. Why? Because in concave lens we only get an erect image, right? But in convex lens we get both erect as well as inverted image. So that's why in convex lens it can be positive or negative, but in concave lens it will always be positive. Next, the magnitude of magnification is greater than 1 for magnified image. If the magnification is greater than 1, it means that the image is magnified, the image is bigger compared to object. If magnification is less than 1, the image is diminished, the image is smaller. If magnification is equal to 1, the image is of same size. If magnification is greater than 1, the image is bigger compared to object. It is nothing but magnified image. If the magnification is less than 1, it is diminished image. It means that the object is larger than image formed. Okay. If magnification is 1, the object size and image size will be same. For concave lens, remember, magnification is always less than 1. For concave lens, magnification is always less than 1, because in concave lens we know that the image formed is erect, that's why it is positive m, and always diminished, that's why it is less than 1. Positive and less than 1, positive and less than 1. Why? Because it is erect and diminished. But for convex lens it can be greater than 1, equal to 1, or less than 1 depending on the object position. Whether we will place it below beyond 2f1, between f1 and 2f1, or at anywhere. If you place in that way, it will change. It can be greater than 1, it can be equal to 1, or it can be less than 1. Okay. Power of lens. How do we measure the power of lens? The deviation of incident light rays produced by a lens on refraction through it is the measure of its power. See, this is the lens. Okay, if the rays are coming like this, it will get deviated, right? The angle of this deviation is nothing but power. The angle we are measuring here is nothing but power of lens. So this will be of 1 meter. This will be 1 meter, and this is focal length f. So from here, tan theta will be equal to theta, because for rays coming from infinity, these rays are coming from infinity, right? Angle will be too small, theta. That is nothing but opposite by adjacent, that is 1 by f. This is nothing but power. This is our what? Power. Power is nothing but 1 by f, and f should be in meters. Focal length should be in meter. A thick lens of short focal length and it deviates the rays more, while a thin lens of large focal length. Right? Thick lens of shorter focal length. If the short focal length is shorter, it will deviate more. It means that there is more power. If the focal length is larger, it will deviate less. It means that there is a less power and it deviates less rays. Hence, power of lens is expressed in terms of reciprocal of focal length, 1 by f, and its unit is diopter. Symbol is d. Okay, so power is nothing but 1 by f. Next, the power of lens depends on the direction in which it deviates the light. If it converges, if the lens deviates light towards its center, it means that if it converges, its power will be positive. If it converges, that is nothing but for concave lens, it will be positive. Convex lens, it will be positive. If a lens deviates light away from its center, the power is negative. Therefore, power of convex lens is positive. So power of concave lens will be negative. So convex lens of focal length have 20 centimeter has the power of 5 diopter, 1 by 0.2 meter. We have to keep it in meter, right? So power will be plus 5 diopter. A concave lens of focal length 20 centimeter has the power of minus 5 diopter. For concave lens it will be negative, for convex lens it will be positive. Combination of lens. If we combine two lenses like this, one by one, whose power is P1, P2 and P3. So total power will be P1 plus P2 plus P3. We can simply add them. Or if they have given focal length f1, f2 and f3, so we can write 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3. See, if two thin lenses are placed in contact, then the power of combination is equal to the algebraic sum of their individual powers. Just we need to add them. See, example, plus 2 diopter convex lens and minus 2 diopter concave lens in contact will have 0 power and behave like a glass plate. Simple like a glass plate it will behave. Okay. Next, we'll solve some questions. So the first question here, for a convex lens, the minimum distance between an object and its real image in terms of focal length is given by, let us see, this is a convex lens, here is an object, so there will be an image formed here somewhere, here there is an image I, this is I, this is object O, OBL, right, because optic center is also O, right, this is image. Now let us consider this distance as x. This total distance is d, right? This we need to calculate. What is d? Minimum distance between object and image. Distance between object and image. Let us consider this as x. So this will be d minus x. We need to find out. So what is the formula? 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by, what is v here? V is d minus x, that will be positive because it is this side. So d minus x minus 1 by, what is u? U is x, and if it is left side we have to take it as negative. So minus of minus plus x. So 1 by f is equal to, we'll take it LCM. What we have to do? We have to multiply this here and these both. So x into 1 x plus d minus x into 1 d minus x divided by d minus x into x, right? So plus x minus x will get cancelled out. So 1 by f is equal to d divided by dx minus x into x, x square, right? So if it goes here, dx minus x square is equal to fd. If this both comes here, minus x square will become plus x square, plus dx will become minus dx, plus fd will be equal to 0. What does this mean? This is a quadratic equation, right? This is a quadratic equation. For real roots, b square minus 4ac should be equal to 0. Now what is a? A is nothing but 1 here, and b is nothing but minus d, and c will be fd. So b square means minus d the whole square minus 4ac, a is 1, into c is fd, should be equal to greater than or equal to 0. Should be greater than or equal to 0 for real roots. For real image, they have asked about real image, right? See, it's real image. Okay, now minus d the whole square is d square minus 4fd should be greater than or equal to 0. So d square, if it goes here, should be greater than or equal to plus 4fd. So 1d and d gets cancelled out. So d minimum should be greater than or equal to 4f. D should be greater than or equal to 4f. Easy? Yeah. Next question. An object of height 20 centimeter is placed in front of a lens of distance 50 centimeter. Height of object is given how much? 20 centimeter. Is placed in front of the lens at a distance of 50 centimeter. It means that object distance is how much? 50 centimeter. So we have to take it as minus 50 centimeter because object distance is always negative. It's virtual. First thing, diminished image is formed at a distance of 15 centimeter. They have given image distance plus 15 or minus 15. Firstly, virtual and diminished is the only property of concave lens. For concave lens, image distance is always negative, minus 15 centimeter. Okay. Identify the type of lens. It is nothing but concave lens because it is forming the virtual and diminished image. In concave lens, the virtual image is formed with magnified image, right? Magnified and virtual image is formed. Here, virtual and diminished means it means that it is a concave lens. Calculate the focal length of the lens. Simple. So we'll calculate the focal length. 1 by f is equal to 1 by v minus of 1 by u. So 1 by u is equal to 1 by, what is v? V is minus 15, minus 1 by u is minus 50, minus of minus plus 50. So 1 by f is equal to, what we have to do? We have to cross multiply, right? LCM. 50 into 1, 50, minus 15 into 1, minus 15, 50 into 50, 15 into 50, sorry, 15 5s are 75. So we can take it as minus 750, right? Minus 750, 750. Directly 750. Okay, next. We'll do it here. 1 by f is equal to 50 minus 15 is minus 35 divided by 750. So f is equal to 750 divided by minus 750 divided by 35. So 5 table, 5 sevens are 35, 5 ones are 5, 5 fives are 25, 0. So f is nothing but minus 150 by 7 centimeter. This is nothing but the focal length. It will be 21, 22 something, 21 point something. Okay, we can calculate it. Next, an object is placed at a distance of 24 centimeter in front of a convex lens. Which lens? Convex lens. U is how much? Minus 24 centimeter because it is always negative. Of focal length 8 centimeter. And we know that the focal length of convex lens is always positive. So f will be 8 centimeter. What is the nature of image so formed? What will be the nature of image? So first thing, we'll see what is the object distance. Is it beyond 2f, across 2f, or at 2f? See here. Let us see. 2f is nothing but distance of 2f is r. R is equal to, see, 2f will be radius of curvature, right? So r is nothing but 2 times of focal length, right? So r is equal to 2 into focal length is 8. That is nothing but 16 centimeter. But therefore object is placed beyond 16 centimeter. That is nothing but 24 centimeter. So the image is formed between f1 and 2f1. Sorry, f2 and 2f2. f2 and 2f2. If the image is formed between f2 and 2f2, it will be, the image is real, inverted and diminished. Real, inverted and diminished. Remember. Next, calculate the distance of image. So 1 by f is equal to 1 by v minus 1 by u. So if this u goes here, we need 1 by v, right? So 1 by v can be written as 1 by f plus 1 by u. So you will have to comment what will be the image distance for question number 3. Okay. Next, a convex lens of focal length 10 centimeter is placed at a distance of 60 centimeter. What is the focal length here? 10 centimeter, which is the lens? Convex lens plus 10 centimeter. Is placed at a distance of 60 centimeter from a screen. Okay. How far from the lens should an object be placed? We need object distance so as to obtain the image, real image on the screen. So screen distance is nothing but image distance because image is forming on the screen, right? So this is nothing but image distance. Image is forming on the screen. As it is the convex lens, image will form here mostly. A real image, right? So real image means it will form here plus 60 centimeter. Simple. So we need u. So let's find out u. 1 by f is equal to 1 by v minus 1 by u. So 1 by u, if it comes here plus 1 by v, if 1 by f goes here, it will become minus 1 by f. So it will be 1 by v is what? 60 minus 1 by 10. So 1 by u is 10 minus 60 divided by 600. We can take directly LCM as 60, but you remember that cross multiply, then multiply these two. 10 minus 60 is minus 50 divided by 600. 0, 0 gets cancelled. So u is equal to minus 60 by 5. 5 ones are 5, 5 12s are 60. Therefore, object distance is minus 12 centimeter. Object should be placed at the 12 centimeter to obtain a real image on the screen. Easy? Next thing. An object is placed at a distance of 12 centimeter. Okay. U is minus 12, sorry. Minus 12 centimeter from a convex lens of focal length 8 centimeter. So F is what? 8 centimeter. Find the position of image and nature of the image. Exactly same question. Here they have given these two. We need this one. Here they have given this and this. We need V. Opposite of that. See, we'll get V60 only. See, 1 by F is equal to 1 by V minus 1 by U. So if this U comes here, 1 by F minus 1 by U is equal to 1 by V. 1 by F is 8. Minus of minus plus 1 by U will be 12 is equal to 1 by V. So 12 plus 8 divided by 12 8s are how much? 94. 94 or 96? 96, yeah. Is equal to 1 by V. 12 plus 8 is 20 divided by 96 is equal to 1 by V. Oh, it's coming less, sorry. My bad, my bad. So 1 by V. V is nothing but 96 by 20. V will be equal to 96 divided by 20. So how much it will be? 24s are 80. It will be 16. So 0.8. 4.8 centimeter. Is this correct? Just a minute. Object is placed between F1 and 2F1. So image will be formed beyond 2F1. That is wrong. We might have made some mistake. That's why we should get 60 only. See, here we'll get 1 by F. If this U comes here, oh, it will be plus 1 by U. So 1 by V is equal to 1 by F is what? F is 8 plus into minus 1 by 12. So here 12 minus 8 divided by 96. Yeah, now it's correct. 12 minus 8 is 4. 4 by 96. Correct? 12 minus 8 divided by 12 8s are 96. Yeah. So V will be equal to 96 upon 4. 4 2s are 8. 4 4s are 16. That is nothing but 24 centimeter. It does not come 60. It is 24, but plus 24 centimeter. We got how much? 24 centimeter. That is beyond 2F2. It's correct now. See how you need to calculate. We got 4.8. It is nothing but between F and O. In convex lens, we are not getting any image between F and O. Right? So I cross checked it. So we got how much? 24 centimeter. And the nature of image is real, inverted, and magnified. Next. A lens of focal length 20 centimeter forms an inverted image at a distance of 60 centimeter. U they have given 20 centimeter, sorry, F they have given 20 centimeter and V is 60. V is plus 60 centimeter because it is an inverted image. Okay. Identify the lens. It is nothing but concave, convex lens, right? Because inverted image will form in convex lens only. How far is the lens present in front of the object? Any U we need to calculate. So 1 by F is equal to 1 by V minus 1 by U. So if this 1 by U comes here, it will become plus. So 1 by V minus 1 by F. So you will comment down the answer. What is U here? Okay. In question number 6, calculate the magnification. So magnification will be V by U. Again, you will comment down this answer as well. So these two answers you need to comment down. U is equal to so and so and M is equal to so and so. Next. An object is placed at 2F position on convex lens. Draw the ray diagram showing the formation of the image. Okay, convex lens, right? This is a convex lens. This is our optic center. This is f1. This is 2f1. This is f2, and this will be 2f2. So the object is placed here, right? So we will take a straight line. It will pass through f2. Another line. It will pass here. So the image is formed at 2f2. Okay, simple. How will the size of image change if we only replace the lens in the above arrangement with another lens of greater focal length? The size doesn't change. Why it doesn't change? Because magnification does not depend on focal length, right? Because magnification does not depend on focal length. Okay. Next. An object is placed in front of a concave lens at a distance of 45 centimeter from it. U is minus 45 centimeter. If its image is formed at a distance of 30 centimeter, V is, which is this lens, concave lens. So image will also be minus 30 centimeter. Calculate the focal length. F we need to calculate. This will also be minus only. So we'll calculate it here. 1 by F is equal to 1 by V minus 1 by U. So 1 by F is equal to 1 by minus 30 minus of minus plus 1 by 45. So 1 by F is equal to, we'll cross multiply. 45 into 1 is 45 minus 30. 45 into 30 will be 1350. Okay. 45 minus 30 will be how much? 45 minus 30 is 15 divided by 1350. Right? Just a minute. 45 minus 30. Sorry, 45 plus 30, right? If I take it plus 30 here, (45 minus 30). It will be 1 by 45 minus 1 by 30, right? So if I take LCM as 90, it will be 2 minus 3. Just a minute. See here. It is 1 by minus 30 plus 1 by 45, right? So I can write it as like this: 1 by 45 minus 1 by 30. Correct? Yeah, because it goes here. LCM of these two will be 90. It will be 90 because in both the tables 90 is present. In 45, what will be 90? Where will be 90 present? 45 into 2 will be 90. So 2, right? Minus this minus as it is. 30 into 3 will be 90. So we'll substitute 3. 1 into 3 is 3. So 2 minus 1 is minus 1 divided by 90. So therefore it will become F is equal to minus 90 centimeter. F will be minus 90 centimeter. Okay. Okay. Next. An object is kept at a distance of 15 centimeter. U is equal to minus 15 centimeter as usual from a convex lens of focal length 10 centimeter. So F is equal to plus 10 centimeter. Calculate the image distance and state the characteristics of the image form. Same. So 1 by V is equal to 1 by F plus 1 by U. You might have note this how I form this formula. So 1 by V is equal to 1 by F is 10 minus 1 by 15. So 1 by V is equal to, what is the LCM? LCM will be 30 because in both the tables 30 is present. 10 into 3 times will be 30 minus 15 into 2 times will be 30. So 3 minus 2 is 1 by 30. V is equal to how much? 30 centimeter. So the image is real, inverted and magnified or diminished. It is forming beyond 2f1. It is magnified. Next, the last question. If the magnification produced by lens is minus 0.5, magnification is negative. What is the correct statement? Magnification is negative for which? For convex lens. Okay. The lens is concave, no. the image is real, negative is for virtual image, sorry, the image for real image, the image is virtual, no, the image is magnified minus 0.5 less than 1, so it is not magnified, it is greater than 1. If it was there greater than 1, it would be magnified. No, the image is real, okay, diminished, yeah, formed by convex lens, yeah, option D is the right answer. Done. So by this we'll complete this part, that is part C. We'll be meeting in the next part, that is magnifying glass. Okay, so let's talk about it in the next part. Till then, keep studying, keep writing, keep studying, keep downloading Easy Notes app, and keep studying everything. Keep following us. Okay, we'll meet you in the next class. Bye bye.